Kubernetes, OpenShift, Docker, containerization, and application which is ready to move in the cloud. So start our journey, and we will first talk about what is the cloud computing. So cloud computing is nothing. It is a server-based computing facilitation to the organization who wants to deliver their applications using the web platform, primarily from the web platform or the remote platform. We understand that, okay, earlier we are having our own data centers or we are serving our applications through the offline mode, like we are developing applications, packaging it into the exe format or delivering it to the customer through the CD-ROM or some offline media like through the pen drive or through the hard disk. So what we are doing, we are developing applications, we are packaging applications into the platform dependent binaries, whether it may be a exe file or a jar file or anything, and then we are delivering it through offline channel like through CD media, or we are using web portal also to deliver the content so that the customer can download the artifact, so that the customer can download the software and install on their own machine. Then in the next generation of application delivery, we got the internet, which is a hosted platform where you are not delivering the application in a offline manner, but you are installing a server and user will able to access the software through the browser. So all the business logic and all databases are now shifted from the client LAN, client local area network, to the cloud, to the server, which is hosted somewhere else or some other part of the. Then when we graduated, we moved further in our application development style. We felt that we can serve the software as a service also. And as the availability of the internet, as the availability of the network increased, user base is also increased for the applications. Now scalability becomes the challenge. How? We have limitations on the increase of hardware powers. Means we cannot vertically scale, and there is a limit to some extent. Like for an example, if you are having a server in which you are having 16 GB of RAM, you can install 32 GB. You can upgrade it further to the 64 GB. You can go up to 120 and 128 GB, 256 GB. But after that, you will feel that, okay, their hardware specification has their own limitations. So we started scaling our application from vertical to horizontal, and we introduced some virtualization. We introduced some virtual machines, VMs. VMs runs the whole host operating system as a guest operating system. So VM takes as much as space in term of RAM, in term of storage, as the host machine is having. Again, it becomes a bottleneck in the horizontal scaling. So we come to the next generation of application deployment in the form of container. Containers are very lightweight application deployment, way of application deployment. In the containers are nothing. It is a process basically. It is the very much one process in your Linux operating system. And in Linux operating system, we term as everything as a process, everything as a file. So partitioning the file, partitioning the process is easily done in the Linux environment. So you will see that most of the containerization platforms runs only on Linux. Then we are coming to the popular platforms. We are having public, private, hybrid cloud environments. For an example, Amazon Web Service, Google Cloud, IBM Soft Layer, Digital Ocean. These are all the public hosted cloud environment. They sell their bit of processing power, bit of storage, bit of network capability to their customers and charging as you use, pay as use. This is the model mostly cloud operators are doing their business in this pay as you use model. But when the cloud computing world improves, or they move to the OCI, Open Container Initiative, whatever the word I am telling you, please note down all the words so that later you can explore more on these topics, on these buzzwords. Whatever I am talking, these are the fancy words in this cloud world. So we are talking about, okay, we understood that there are many companies, many internet companies providing the computing facilities to their customers using the public cloud platforms. Most popular are like Amazon Web Service, Google Cloud Platform, GCP. IBM has their own system called IBM Soft Layer. Digital Ocean is another very good example of public cloud infrastructure provider. And there is a basically association, there is a community which take cares of the development of tool, platform, libraries, plugins, everything. It is known as the OCI, Open Container Initiative. And many of the company name I have just given you example, they are the member of this community. Red Hat is also member of this community, Open Container Initiative. So just like you know that, okay, in the world of open source software development, there is Apache Foundation, there is Eclipse Foundation. So these are the basically key player of the open source application development. Similarly, in the area of cloud, OCI is the key player of open source based application development and maturing the system, maturing the environment, maturing the platform. Now come to the private. So we can host cloud environment in our very much private servers also. No problem in that. So we can run very much same set of softwares what they are running in the public cloud. We can run those softwares in our private cloud also. So when we run these type of platform in our very much own private infrastructure, it is called private cloud. So there is a OpenShift, OpenStack, VMware. All these are providing you facility to host your private cloud on your private infrastructure. We can connect two clouds also. Two private cloud can be connected with each other. One private cloud can be connected to the public cloud. Two public cloud also can be connected with each other. So whenever we are having more than one environment and we are connecting these two environments to make a very big powerful system. For an example, we can say that, okay, we will take our production environment in the private cloud, but we will have similar setup in the public cloud also to take care of any disaster recovery. So that kind of arrangement is called hybrid cloud. So now we are moving to the common dictionary. So in this tutorial, whatever we are having session, a long session of 4 hours, in these 4 hours, we will talk about these many terminologies, words. So images, Docker, I will discuss about all these words during the whole session. Earlier we were calling our application as a exe file or installer file. So image is the counter word of the your application software. You are creating jar, you are creating exe, you are creating any other deployment unit of your application. In the cloud world, we are calling it as a image. Image is your offline software which is not running anywhere, which can be run on any of the cloud supported environment, or we can say image can run on any cloud compatible environment. Okay, so now we are moving to the next word, containers. Containers are just running mode of the images. Images are the offline zipped, or you can say software as exe, which is not running anywhere, and containers are the processes basically which is running. The running mode of the image is called container. Then pod. Pod is another synonymous of the container. There is a little difference that one pod can have multiple containers, but in most of the cases there is a philosophy of having one container per pod, and we can combine two containers to serve in conjunction with each other, and we can term it as a pod also. So again, when we are running one more than one container inside one single unit, which is known as the pod, then there are the way they will interact with each other, like ambassador design pattern, or your 2-3 more design patterns we are having to arrange the multiple containers, like sidecar, ambassador, and adapter. These are the three way we can arrange the containers inside the pods. Now, Docker and Podman. So Docker is the open source solution to manage the containers and images along with their storage hosting of the images called registry. So Docker is having one registry, and there are many other registries are also available from where we can download the images. So image registry is a way to circulate, to facilitate your application to your customer. So again, we are having two different type of applications. One, we are creating for our client, and that will be used by only our client only. But the other things are also, for an example, Postgres application server, Postgres database server. So Postgres company has created it and provided it as a free open source solution for the database management system, and they are making available of their exes from their website also. So in the same manner, Postman is also providing their Docker images, and they are putting their Docker images in the Docker registry. So Docker registry is a public place from where anyone can download Postman database. Similarly, other applications owner are also providing their application images in this type of public repository, so that the wide community or the customer can download freely from this image repository or image registry. So again, Docker registry is not the only one place available for hosting public images or for hosting images publicly. Another example is QA. quou.io. I think we will see this URL further in our examples. So now we are moving to the next word, which is the podman. Podman is the Red Hat version of this Docker. So again, it is a community driven one second. Talking about what is podman. On the website of the Red Hat, first of all, podman is the command line tool to manage the images, to manage the containers, to manage the pod. It is provided by the Red Hat. So it is the Red Hat version of the Docker. And on their website, they are claiming that the podman is the drop-in replacement of the Docker. It means whatever the command we are using with the Docker tool, we can use the same command with the same switches and for the same purpose using a podman also. But practically there is little difference. So we will talk about what is the difference between the Docker and the podman, and to what extent it is common, and where these two tools are different from each other. We will talk about this later in this session. Then why we are talking about so much about the images, about the containers, about the pods, about the Docker, podman, because we want to run our application in very limited resources, and we want to manage our applications from the failure. So orchestration, another word is in the cloud application dictionary, is the orchestration. Orchestration means based on the demand, based on the application health, applications should be able to scale their instances, and if there is any problem with the application health, it should be able to heal at their own. So there is two main concern about the application runtime, that it should be scalable, means when there is more demand, when there is a more requirement, then we should not worry about the number of instances. It should be auto scale. So if I am running my application with the help of one Tomcat and there is increase in the demand, it should be automatically replicate to the two instances of the Tomcat, so that my customer can get the services from my website. So this is called auto scaling. And if one of the node is not healthy, if one of the node is dying, or if one of the node is not responding well, it is taking too much time to respond, then this node should be discarded and some other healthy node should take care of the application runtime. Or if one particular VM is not healthy, it is not available, or it is just having some problem in the network, in the storage, or any kind of health issues of the VM, then the orchestration tool, the tool which is responsible to manage the application, it should discard that particular VM, that particular node, and automatically install my stuff, my application, to some other healthy node. So this functionality is known as auto healing. Then I would like to run my application and I would like to observe the overall process, overall health, overall availability of my application. That is called observability. Why it is that much important? We can say that, okay, we are writing logs in our application, we are having other application monitoring tool deployed to take care of the what is going on inside my application. I am processing the log. I am doing the application management uh, through the tools also. Then why the orchestrator should observe my overall cluster health? Because this is the feature so that it can be decided by the orchestration tool when to scale and when to heal. Then security. If I'm running my application on the very much host, then it has access to all features of the operating system also. But we want to run our application in a very limited with the very limited resource and with the very limited accessibility to the system. So Docker and Podman, these are the two processes basically. By default, Podman is a rootless process, and Docker is a daemon-based process. So Podman is their basically their main feature what they are marketing is that we are daemon less. Docker is daemon oriented, so somehow there is a layer between your application and there is your application and the host operating system, and the daemon is being controlled by the host operating system itself. In the Podman there is no daemon, so one layer is less in the Podman or the Red Hat solutions, which we will talk today in the second part of this session also. So now we have seen that okay, in the cloud world, in the new generation, we want to run our application with the very limited resources. Applications should be auto scalable. Applications should be have functionality to heal itself. So all these two terms are known as the orchestration, observability, and multi-tenancy. Means my application can run in different data centers as a one application, as a one unit of solution, as a one unit of service. That can be also managed easily through the orchestration tool. For an example, Kubernetes. Kubernetes is the most popular orchestration tool in the world of containerized application. There are other orchestration tool in the market, but in this session we will talk about Kubernetes, and OpenShift is built on top of the Kubernetes. So OpenShift and Kubernetes, these two are the replacement or the companion of each other. Similarly, you can run whatever the command you are running on the Docker command line tool. That same command can be used with the Podman also. In the same manner, whatever the command you can use with the Kubernetes solution, same command can be used with the OpenShift solution also. So now there is two things, Docker Compose. So there is no problem. Docker-compose is the version 1 of the Docker Compose solution, and Docker space compose is the version 2 of the Docker Compose solution. And Docker Compose is the way to create multi-container images. To create one container, you can go with Docker file, and to create multiple container, you can use Docker Compose. We will see the example of these two things, container and multi-container, later in this session also. We have already talked about image registry. So the popular image registry is hub.docker.com. Similarly, other image registries are also available in the on the internet, which is freely available, and we can create our own very much private image registry also. I would like to take here an example of GitHub. So we have public GitHub where we can post our source code, we can manage our application version, source code version. And in the same manner, we can host the same software in our own infrastructure, and we are knowing it as our private source code repository, our private SVN, or our private Git. Similarly, we can host our application on the public image registry, or we can set up our own private image registry where we can put the images, so that we can pull it from the registry and run it as a container. So image registry, container, and then management of container is known as the orchestration. In the management, there is two things. One is the scaling, other is the healing. These things are the buzzword. These things are the common dictionary word we will regularly use in our day-to-day life when we go for the cloud-based application development. 2-3 more words coming into my mind is cloud-ready application and born in cloud. So, for an example, if we are writing APIs and we are making WAR file to host it, it means there is automatically we are saying that, okay, this is my API application. I have built it in the form of WAR file, and it can be hosted in any Tomcat which is already running. Means there is a Tomcat in the running state. It means Tomcat is working fine. Tomcat is there, already there, and you are just providing the WAR file. So again, so this is not the cloud ready. Why? To run this particular WAR file in the other Tomcat, I have to host it manually. Or if I'm using some Tomcat farm or any tool, then again also I have predefined number of Tomcats. Okay, for an example, if I am having 5 Tomcats and I'm saying that, okay, my application is scaling up to 5 Tomcats, because it is predefined that I will have 5 instances of Tomcat. And I'm not providing the runtime environment. That is Tomcat. Means I am only providing my application. I am not providing the runtime environment. I'm not providing the Java. So typically in the containerized world, in the cloud application or in the containerized application, we are packaging application with the server in which the application is going to run, and along with the dependency. What is the dependency in this case? Java runtime. Because my API will be run on the Tomcat. Tomcat will run with the help of JRE. So there is a JRE, there is a Tomcat, and my application. So if I am packaging all 3 things in a single unit, and then I am making a sidecar, or I am making my logs in a central log repository, then I can say, okay, this is my image. This image contains the runtime, the dependency, and the application. All 3 things are packaged in a single unit. You can deploy it as many times you want, and each deployment will be covered by JRE, it is already there, Tomcat, it is already there, and my application, it is also already there. So the environment, server, runtime, and application, all 4 components, all 3 major components is grouped into one single unit. Then we are saying that, okay, now my application is cloud ready application. my application is cloud ready application, because there is no further dependency, there is no further requirement to run my application. My particular image is containing everything which needs to set up the runtime, which needs to run the application in term of logic, in term of runtime, in term of server. Everything is packaged in a single unit. That single unit is called images. So if I am providing my application in the form of image, not in the form of war file, then I can say, okay, my application is now in the form of image. It is a cloud ready application. It is a cloud ready application. Okay, got my point? Everything is clear up to now. Shall we go ahead? Okay. So we have understood what is the containerization. Containerization is the making your application. Containerization is the process basically which runs your images, and images is the combined unit of your JRE, your Tomcat, your application, your custom business logic. Everything is packaged into one unit called image. And when we run this image on some containerization platform like Docker, like Podman, like Kubernetes, like OpenShift, we are knowing it. The running mode of the application is known as the container. So I have here one link simple. So to know more about what is the container, best thing is to go to the official documents. And where you can find the official documents, it is the OCI, Open Container Initiative. They are hosting the best content for the container related knowledge, container related topics. They are the author of these things. But for the very basic knowledge, you can go to my site agile.ambrisia.in, and here in the Kubernetes you can go to the container link also. And I will provide more detail on this website time to time so that you can get more relevant information. So in the Kubernetes world, containers are the fundamental unit of packaging and deploying application. Container provides a consistent and isolated environment. Why isolated? Because it is carrying all the necessary components which are required to run the application. We have already talked about this. For the running the application and their dependencies. Kubernetes uses the container as the building block of the deploying, scaling, and managing. Managing means observability, to look the health of the container, to look the health of the application and all. So you can read this blog and you can read more on the official site of the OCI also. Podman, again, so Podman is an open source containerization tool, just like Docker. Podman is a solution for the creating, running, and managing containers. But Podman goes beyond Docker. Means first we introduced with the Docker, and after a few years, Red Hat come up with their own alternative of Docker known as the Podman, using a secure daemonless process to run the container in rootless mode. All these words are heavy words. All these words are catering a big meaning. Means using a secure daemonless process. This is not the simple word. Okay, one more thing. To work with the containerized applications, to work with the Kubernetes, to work with the Dockers, we have already talked that all these things are primarily running on the Linux. If you are using the Windows machine, And if you are using the Docker desktop, you can see that window is running one virtual machine behind the Docker desktop, and the commands are supported by the that virtual machine. Docker desktop is backed by a virtual machine, which is again Linux based machine. So basic Linux is necessary to do the day to day work in the this containerized application development. Every time you have to run some of the command on the Linux terminal, or if you want to go inside the container is a running environment, container is a running instance of the image. You can jump into the container, but 99.900% running environment of the container is some kind of Linux environment. Again, to deal with the Linux environment, you should know the basics of Linux. Just basic. ls, cat, nano, cd, mkdir, rm. Rm command is used to delete the file. And similar basic command to just operate the very minimum basic things. Copy from the container, copy into the container. Again, there is some Linux command to do this. Basics of some communication tool like scp. Again, it is for copying the things. Telnet. All these are very basic command. ifconfig, ip tables, looking into the service processes, means Linux processes basically. So to work with container, to work with Docker, to work with Podman, to work with Kubernetes, OpenShift, or altogether in the containerized application development world or the DevOps world, certainly you need to know basics of Linux, or you have the mindset to learn basic of Linux. If you know more than basic, definitely it is good for you. Okay, in general window operating system, what we are doing, we are downloading the application in the form of exe and running using the double click tick tick. In the Linux world, most of the time we are downloading the application from some of the repository. If you are using Red Hat based Linux, then there is a yum repository and yum command to list, to search dependencies, tools, packages. If you are using some Debian based Linux, Ubuntu or Debian Linux, anything, then there is a apt command, apt-get command to download the applications, to download the dependencies, to download the packages, to download the RPM. So definitely, if you know basics of Linux, then good. Otherwise, learn little handling of the Linux operating system, handling of the Linux processes, so that you can easily understand what is going on in the container, with the container. Okay. So again, coming back to the Podman. So Podman is it is Red Hat claiming that okay, this is more secure. How this is more secure? Because we are running the daemonless process. Now, if you know something basics of Linux operating system, and what is the daemon in the Linux operating system, and how it is tightly coupled with the host operating system, how it is tightly coupled with the root or admin portion of the operating system, then you can understand why daemonless process is more secure in Linux, and what the daemon means in the Linux operating system. and what is the root powers, and what will happen if a process is running in a rootless mode. So basically Podman claiming two things. One, it is daemonless. Other, it is rootless. So to understand what is the daemon and how it is meaningful and how it is useful to have the daemonless to provide the security, and what is the root, what is the capability of root in the Linux environment, Linux operating system, and how it is going to affect security and how it is going to improve security if you are running the processes, if you are running the applications in the rootless mode. Then definitely, that's why I took little time to explain that, okay, if you are going to work with the Docker things, certainly you need to know Linux also. Not at the very much server admin level, but at least little day-to-day activity means little hand holding of the Linux environment is required to properly work with Docker Podman or any other containerized solution. Docker versus Podman. Podman and Docker shares the role of containerization tool. Both are the containerization tool. Each facilitates the complete initialization, deployment, and administration of the container. This is the similarity. Nevertheless, both tools exhibit distinct advantages and drawbacks. The forthcoming sections in which we will delve into the aspect of each tool, and we will see, okay, we will know, I think we cannot see the Docker because if we are installing both of the tool on the same machine, only one tool will be active. So I can show you how the Podman is working. Whatever I will run with the Docker, behind the scene, Podman will catch it. Podman will take over the Docker commands. So this is the pros and cons of each tool. Docker is simple, approachable in the term of help. Docker has wide popular. Docker has wide support. So if you are searching something on the internet with the name of Docker, you will get more results, you will get more help. Docker is daemon based and Docker process runs with root privilege. These are the two Docker cons, means these are the two Docker demerits, but demerits in term of security only. If you are running Docker in your development environment, then these two things doesn't make much sense, because in your development environment, security is not that much concerning thing. So we can say that, okay, in the development environment, you can go with the Docker also. On the Podman website, they are claiming that Podman is the drop-in replacement. It means in your organization, if you are having server environment set up with the Podman and OpenShift, and in your development environment, you are working with the Docker, no problem in that. Whatever the command you will run with the Docker, the same command can be run with the Podman. Vice versa is also true. Whatever the server admin is running with the Podman, same command can be run with the developer on their desktop using the Docker command. So Docker and Podman is compatible in terms of running the command, vice versa. And if help is more concerning thing, if you are looking for the popular solution, then you should go with the Docker. Similarly, Podman pros, again, whatever the Docker demerits, reverse of those demerits is the merits or the pros of the Podman. So in the Docker, we have seen that this is the cons of the Docker, that daemon based architecture. Pros of the Podman is it is daemon less architecture. Cons of the Docker is it is a daemon process with root privileges. Pros of the Podman is it is a rootless process. So these are the things. Again, access to image repository, I have not seen any problem of accessing the image repositories from the Podman or from the Docker. Both can be configured to connect with multiple repositories. No problem. It is a matter of setting only. So that is not the very big pros of the Podman. What are the cons of the Podman? Is it is limited build feature. Docker has a rich in the build feature also, and whenever you are trying to make complex things using the Podman, it is asking you to go with Builda. Builda is another community. It is the sub community, I would say. It is not the full community. It is a subset of OCI, and they are working on the image building part of the containerization process. So Red Hat is depends on the Builda to make complex images, and Podman they are proposing Podman for the development activity by the developers and for simple management of images, containers, and observation of the container. You can effectively use Docker and Podman side by side. No problem in that. You can use in your production environment, you can use Podman. In development environment, you can use Docker. Vice versa is also true. In your development environment, you can use Podman. In your production environment, you can use Docker. No problem in that. Considering both tools are OCI compliant. OCI stands for Open Container Initiative. This is the main community which is taking care of this containerization portfolio or containerization work. Indeed, it is entirely feasible to employ Docker and Podman concurrently, given their adherence to OCI standards. Both instances, you might opt for Docker within your developmental settings, focusing on crafting application images while prioritizing security for a lesser extent. We have already talked about that. In the development environment, security is not that much concerning things. Subsequently, you can leverage Podman to execute and uphold these images within a production environment. Means both tools are compliant with the OCI. So you can mix these two things, no problem. Okay, now it's time to do some practical. So I am opening my terminal, and I think it is visible to you. Okay. So I have already installed the Podman. Just like, okay, just go to the website. What you can do if you are using Windows machine, then you have two choices. One is Docker Desktop, no doubt. Docker Desktop, which you can install. Or if you like to use Podman, then same, there is a Podman Desktop, which you can install. So containers and Kubernetes for application developers, Podman Desktop. This is the tagline of the Podman Desktop. And Docker Desktop, install Docker Desktop, the fastest way to containerize your application. Both tagline is similar. Both is saying, okay, we will help you to containerize and test and build your images. But I'm not that much fan of the UI things. So I will only demonstrate, and I am only using the command line version of this podman or the Docker. So I have already installed podman in my machine. You can install the command line only version using the yum or the apt if you are using Linux flavor. I am using only the Linux things. My host operating system is Red Hat only. Or the Docker things. If you are using Windows machine, best is use either Docker desktop or the Podman desktop. Both will be backed by a virtual machine, and both will give you two things. One is the GUI kind of environment, and one is the shell environment. That is the best shell to interact with your Podman or the Docker. So, one second, version. So I am using the Podman version 4.4.1. And if I am using Docker --, version, you can see that earlier I have installed Podman first. So when I install Docker, it is saying emulating Docker command line interface, emulate Docker CLI using Podman. So whatever, if I run with the Docker prefix, actually it will be run by the Docker or Podman. So let's do some practical and see what we can do with the podman command. It is drop and replacement. So if I am searching Docker search, say Tomcat, and I got some output. These are the images available on the public repository, which is currently configured with my environment. I can configure more repositories, which may be public repository or the private repository or the corporate repository, to get customized images. But as of now, these are the public images. These are the public repositories and publicly available images. And if I'm running the same command with the podman, output is same. So Docker and podman, both are giving me same output. Both are giving me same output. Okay. So this is the proof that they are same. And command is also same. Docker search and podman search. Okay. Now I am searching for the Nginx. So this many Nginx images are available on public repository. Okay, suppose this is official build of Linux. I am taking this as an example. Suppose I don't want to search this image, this Nginx image through the terminal. I would like to search this image from the browser. Then what I need to do? Similarly, I have the idea, okay, this is comes from the docker.io. So let's go with the docker.io, and docker.io is emulated through the hub.docker.com. hub.docker.com. And here, if I'm searching for Nginx, this is, and here I'm saying, okay, I want only official command, nginx, and this is the official. So on the Docker desktop, on the hub.docker.com, This is the public repository. So anyone can upload their version of application. I can also download the source code of Nginx, build it, and upload it under my name. So company is also providing, public is also uploading their own version of the applications with the same name. Sometime to find out, please have some precautions. First, read about some statistics, and then when you are sure that okay, this image is good enough to download and this image is good enough to run, then only run it on your machine. Otherwise, there may be some accidental downloads and you may download some bad stuffs. You may download some compromised images, and that if you are not using the podman, you are using the Docker, then you may be at security risk. You may be at security risk. So better pay attention before downloading the images from the internet, from the public repositories. So suppose I am seeing, okay, this is the Nginx. This is one batch. This is one batch of the official. Other batch is blue color verified publisher. Then there is some statistics. It says 1 billion plus download of this image till date and 10,000 plus likes or star marks are there. And it is having the official tag also that this is the official build. 1 billion, only 50,000. And say there is a lot of other, this is Nginx NC, some name is there, only 414 downloads. So be cautious before downloading the image. So if I'm going to this, it is saying you can download it using the docker pull nginx command. You can use docker pull nginx command. And here are some tags. So tags are the version of the application. Just like you are going to download Tomcat and you are saying, okay, I would like to download Tomcat 8 minor version so and so, or Tomcat 9 or Tomcat 10 or Tomcat 11. And then every major version has their many minor version also. Tomcat 9.0.41, Tomcat 9.0.56, so and so. Similarly, in the image repositories, we can have multiple version of the same repository, same image. For an example, Nginx having this many repository and it is tagged with the number, sometime number only, sometime number name combination. So all these tags refer to the latest one, 1.25.2. Same, this is little different flavor. Little different flavor means this is the standard one. This is using the Alpine Linux as the base image. This is 1.24.0 stable of the 24 minor version. This is 25.2. So many versions are there with the multiple tags. So same image is referred with the multiple tags, and we can have multiple versions of the same image also. So these are the popular recent tags. So you can use the tag also. By default, if I'm not putting any tag, the full command is docker pull docker.io/nginx:\latest. And whatever the image tagged with the latest. So this line, first line is having latest tag. First line is having latest tag. If we are going to this file, This is the Docker file. Docker file is what? Docker file is to build the image. Docker file is to create the image. So, okay, no problem. We will talk about this, these things. What is the label, from, environment, run, execute, CMD and all. First, we need to run this image. Bitnami is also a very popular publisher of the images, and they are also having good followers and very good community, and they are customizing applications. But for now, we will go with the official build of the Nginx. So it is the syntax, like first public repository hosting name, that is, maybe you can use registry.redhat.io, and you can use docker.io. Both are hosting official version of the Linux, official version of the Nginx. So again, we are having registry.access.redhat, registry.redhat, and docker.io. So all three variety of the repositories are in public flavor, but we can configure more private repositories in our podman configuration files. No problem in that. Okay, so we will not waste more time. So this is the image repository name for the Nginx application server. How I can get it? First, let me check whether I am is already podman images. This command gives you the list of all applications you are having in your local machine. So podman search, basically search on the net, and podman images basically will give you the list of all images in your machine only. So we can see that I am having MySQL. Some 2 weeks ago, I have downloaded it, created it. Kibana, Golang, Elasticsearch, OpenJDK, Maven, MyApp. Okay. I don't have Nginx in my local repository, in my machine. So I'm going to use podman pull, and then name of the application, and then name of the application, podman pull. So it will download the Nginx latest tag. I have not given any tag, so it is already appended the latest one, and it is downloading the stuffs for me. So you can see that here many blobs getting downloaded. So each blob is a layer in the image. Actually, in the container, in the containerized application, basically, we are creating layers of the resources. And many of the layers are reused in multiple images. For an example, Alpine is a flavor of Linux operating system. It is minimal in nature, like only 150 MB is enough. It is the only size of the Linux operating system, which is having very limited capability and which can be used to run your Linux based applications. No problem with that. So that Alpine is used by many images. Postgres image is also using Alpine. Tomcat image is also using Alpine. Linux image is also using Alpine. So Alpine can be seen as a layer in your container. So one layer is Alpine, which is common in multiple other images also. So I have used the podman pull and then the name of the application. I have given the complete name, docker.io public image repository /library /nginx. I can use just this much only, docker.io /nginx. It took no time. Why? All the layers are already available on my local machine. So in the first one, you can see that we are getting the message done. It is actually downloading for the first time. But in the second time, when I fired the same query, I have executed the same query, it is saying that all the blobs, all the layers are already available. Now, for an example, if I am going to pull the Tomcat image, and Tomcat is also using the same layer, then that layer will be skipped, and only the layer which is not presently available on my machine, that will get downloaded from the internet. Okay, so now if I now run the podman images command, then it will show me nginx also. Let me run clear podman images. So now you can see here I got this nginx on my very much local machine. Earlier it was not there. Now it is available on my local machine. So we have seen podman search, podman pull, and podman image. 3 commands we have seen so far. Now I am having image with me. That image is available on my local machine, and I would like to run it. I would like to execute it. For that, there is a command podman run, and podman run is asking for the image. Which image I want to run? I want to run this image. So podman run. This command will. So it is starting one application and it is running one. Now my nginx server has been started. But there is a problem. What problem? This particular process is running in a rootless, daemonless, separate environment. So that nginx is running a so-called separate small virtual machine. A very small virtual machine is created to run this application. And you can see that I have used very plain command, podman run, name of the image, which is locally available to me. I have not given any additional statement or additional instruction to how I am going to interact with this application. So if some other terminal, if I am saying podman ps, so it is giving me output. Okay, there is one running container and the name of the container is Keenborg. Again, in the command I have not given any name. So this is a dynamic name. It is podman and docker, both of the platform have predefined pool of name. They are having predefined collection of name, and if you are not going to provide any name to your container, then they will randomly pick some name from the pool of the names which they are already having. So I can see podman ps. Podman ps command is used to, please note down this, all this: podman search, podman run, podman pull. So our fourth command is podman ps. So podman ps command is used to list all the running container processes. Just like ps command on Linux machine will give you processes which runs on your machine, podman ps command will give you the processes run as a container. Podman command as a run as a container. So what the information I am getting right now using the podman ps command? It is the container id, name of the image used to run the container, command used to run the container. That is, this command is basically available in the image only. At what time it is created, what is the status, and what the ports it is exposing. This is the very much important point here. There is no port is being exposed by my container, and I am not able to interact with the Nginx server because Nginx is running inside a VM which is not having accessibility to the host machine and vice versa. But container is running, no problem in that. So go back to the previous terminal. Here my process is running. What if I close the process? I have just issued Control C, terminate signal. Now if I'm checking with the podman ps, container is dead now. Container process is stopped. So now question is that how to run the container which can run for longer time without killing. We can use -d. -d is used to detach the container. Detached container means container will get started and my terminal will not blocked, my terminal will come back. So I am running again same command. Now you can see that earlier it was showing me some logs. Now I am not getting any log. I have just got a message that okay, one ID is being generated in response of your command. My command was to run a container. And if I go here, earlier the name of the container was Keenborg. Now the name is also changed. So because that container is now dead and I don't have provided any name, so this is another container. You can see that container name is also changed. So this is logically this is a different virtual machine running my Nginx. Again, this also don't have any port, so I cannot interact with this Nginx from the host machine. What I can do, I have two choices. One, I can go inside the container, or two, I can export some ports through which I can interact with the application, interact with the application server or the Nginx server, whatever. So again, I'm going to kill the process. So how to kill the process? Now, earlier when it was not detached, Control C was my command to kill the process. At this time, I can use podman command to kill the process. And that command is stop. Podman stop. And then we need to give either the container name or the container ID. Both will work. So it is saying your application is stopped. Podman PS is not returning anything now. So next what? We have run the command without detaching. We have run the command with detaching. And now I want to expose port. 8080 8080. The right hand side is the port inside the container, and the left side is the binding port from the host machine. So containers 8080 port will be available on the host 8080. I can change it, no problem. I can say, okay, I would like to use 7072. Oh, what is this? 707 insert. Oh, my number keys are locked. I would like to say from the inside the container 8080, I would like to my host machine 7070 port run this. Now see the podman PS. At this moment, it is saying on the host machine 7070 is equal to containers 8080 and name is also getting changed. So every time it is creating a new container for me. Localhost 7070. 1 second. I think inside Nginx it is 80 port. (7072). Yes. So how I would like to know which port of the container needs to be exposed? This is again a very good question. Earlier I was missed. I was used Tomcat default port to bind with the host port. In Nginx, the default port is 80. And this information we can gather from the image document. Here is the image document. Two things. One is your very much this thing, hub.docker.com, where you have find the image name. We have searched this image name at this location, and when you go down, they are helping you with some of the normal commands, like you can run the Docker with the help of -d, and then exposing the external port. Here it is, they are guiding you. You should expose the internal 80 port to the sum of the external port. It is not very much restrictive. It is not restrictive to use 8080. You can use anything, just like we have used 7072. Okay. So from their documentation, we can get idea which port they are using default in the image, which you need to access from your host, and we should provide it in the -p. So again, there is two flavor of this, -p or --port. Both is working. Again, if I am going to the Docker file is the description of the image. Here you can also see somewhere they are using 80 port. Somewhere they are using 80 port. See, this is the expose. This is the expose. This expose is the instruction. Okay, host container image will emulate on 80, and during the Docker run command, you are mapping this expose port with your host port. You are exposing this. You are mapping this expose port, that is the 80, with your host port, that is the 7072. So now if I'm running docker ps, I can get there is two images, two container of the nginx image is getting running. One is 7070 port, but inside the container there is nothing which listen on the 8080 port. So that's why my 7070 port is not working. It is not meaningful anyway. But in the second container, 80 port is there. 80 port in the container is available. It is listening and it is bind with the host 7072 port. So in the same manner, you know that few of the attendees of this workshop is Spring Boot application developer. So they know they are mapping every time server.port in their application properties, and that very much application.properties is need to be mapped in the Docker file in the expose line. And when they will run the container out of their images, they will need to map it with the whatever in the application.properties server.port that should be exposed by the Docker file, and whatever the port is exposed using the Docker file, that should be mapped with the host port using the Docker run command or podman run command, anything. Both are the dropping replacement. Now we are running out of time. So I would like to demonstrate few more things. One is the how to go inside the running container. That is a very important command. For that, there is a command podman or the docker, whatever. See, we are running podman ps, getting the same idea. We are running docker ps, getting the same output. So again, there is no difference between the docker command or the podman command, as we have discussed earlier, that podman is the drop-in replacement of the docker. So we can use podman execute hyphen it interactive and then ID of the container or name of the container. ID of the container or name of the container, and then shell, which shell of the container you want to access. Podman execute it container ID pass. So now you can see that this is the terminal of the container. This is the terminal of the container. So in the very beginning of this discussion, practical discussion, we have discussed that container is a very small virtual machine which is getting running as a process on your Linux machine or anything like Docker desktop or Podman desktop. Again, if it is a small virtual machine, then I can have the access to it. I can have the cell access to it. So this is that very much cell. This is that very much terminal of the container. Here you can see if I am going to cd's root ls, this is having something, this type of ls-l, this type of file system, opt, mnt, media, lib, home, etc, and this docker entry point .d, docker entry point .sh. And if I am going to my normal computer, normal machine, and going to this root location, clear ls-l. So this is very much different file system. You can see it is sbin, snap, template, but in the container it is little different. Number one. Number two, here I can see you can use very limited command set because this is a minimal operating system. That's why it is that much low in size. For an example, if I'm running podman images, you can see that this Nginx image is having only 191 MB. And in this very much 191 MB, there is a Nginx server along with the small operating system, maybe Alpine. We can see from which Alpine, from which OS it is getting created. So now it is time to discuss about this Docker file. So Docker file is the basically just like if you are using Spring Boot and you are saying, okay, this is my POM. So POM contains all the list of dependencies, all the list of uh, plugins of the Maven, which you will use in your application. Similarly, in the Docker file, this is the composition instructions for the Docker image. So very much it is the from command. From is the command or the statement for the base image. So it is saying, okay, we will create this Nginx server with the help of base of the Debian. And again, this is the tag, Debian bookworm slim. So this is another image. Our Nginx image will be created based on the Debian image. After that, it is having some environment. We can pass the environment variable. Otherwise, this default will be used. Then they are having set of run commands, which is used to change the basic behavior of the operating system of this Debian, because this command is going to executed on this Debian. It is not going to be executed on my particular host machine anywhere. That's why it is not going to pollute my host operating system. So this run command is going to be run on this Debian to customize this Debian, because this is having their own setup. My Nginx team has decided to run this command in order to set up their operating system environment, their VM setup environment. So this is the set of commands something. Then again, this is the copy command, which is saying, okay, copy this image, this entry point.sh in the root. And this copy command basically will run on this Git source code repository. So basically, again, this is the instruction. This is the instructions on the collection of files which is hosted on the GitHub as a source code. So this is the instruction to build the image, to create the image. To create the image, these are the content of the image. So again, from the beginning, this is the base operating system which will be used to create images. This is the sum of the environment variable. This is the sum of the command to set up the environment of my operating system in the virtual machine. And this is the stuff. This is the content of this thing. And this is the entry point. Entry point means whenever this VM is get executed or this VM get started, this is the default command which will get executed. And then again, this is the expose. So till then we have seen from label, some of the environment, some of the run, from label environment run, copy, entry point, expose, and CMD. This is the command which finally gets executed, and we can have only one CMD command in one Docker file. So this is the command nginx-g daemon off to run the Nginx, to start the Nginx server. Now, important thing is that we can have this much environment variable. We can set this much environment variable. And one more thing I would like to see, that is the volume mount. Okay, no problem. We know that in the etc Nginx file, there is a Nginx conf file which is used to configure the Nginx overall behavior. This is the Nginx detail, not related to any Docker, any image or anything. So this way we have understood one Docker file and what is the contents of the Docker file. Here we have used the Docker execute command. This is my Docker terminal, and I can go and see what is the inside container. Again, container and image both are read only. If your container is not working as expected, then you have to drop it and you have to create a new container. Containers are read only. If I'm making any change here, it is means it will be there, but when I run it again from the image, that image will not have the same setup. It will be vanished. It will be undone. So that's why in the development environment, we keep on creating containers by changing the behavior of the system, by changing the content of the Docker file, by changing the parameters used to create the container. And if it is not worked well, if it is not working properly, we simply remove it. So how to remove the containers and how to remove the images is the next example. What I am having? I am having two containers running. So we have already seen command to stop the container is podman stop container ID. It is get stopped. Then I am stopping the next one. Podman stop another container. If I am checking podman ps, there is no container running on my machine. ps-a, it is showing everything, means running container and stopped container. And if one other command is podman container ls, it is showing nothing, or ls-a, it is again showing the same response as the podman ps-a is giving me. So what I want to do, I want to delete the containers I have created just now. So that container was used to Nginx as the base. One is this container, other is this container, other is this container, other is this container. All these 4 containers we have created just in this session. So one by one, I'm deleting all the containers. Podman rm container ID. Podman rm container ID. Podman rm container. I think last 4 or 5 digit is also working fine. No, first 4 or 5 digit will work. Yes, first 4 or 5 digit will work. Now podman container ls -a. Those containers already deleted. So this worked for me. So we have created the containers. We have deleted the containers. We dived into the container using the container podman-exe command. And we have mapped the port, everything we have did. And we have pulled the container from the Docker hosted repositories, that is the hub.docker.com. Similarly, we have seen that many other repositories are also available. Like one is this is also very popular, QA.io. QA.io is one repository. This is what store your container securely. So again, this is the container repository. This is the image repository, and it supports Podman, Docker, and RKT, all type of containerization tools. So we have seen, we have one this Docker hub.docker. Right? This is another container repository, QA, Docker, QA. We have seen here that okay, Podman images. Okay, this is the local host, nowhere else. Okay, quickly what we will do? Quickly we will create one our own engine application. Whatever we have run so far, it is the Nginx which we have just downloaded from the internet, and we run the container out of it. So now let me open my Eclipse. I will show you one of our simple application, very simple, only to demonstrate that okay, our Java program can be converted into the Docker, this thing. So just this is a simple, most simple application in the Spring Boot. I can show you the pom.xml file also. So you can see that this is the Spring Boot application, and I'm using the only starter web, nothing very much, no database, only one controller here, which is the home, and it is returning you the hello world. This is the only application. So what I need to do, I need to run this command cd, one second, download. And what is the name of this? Demo OpenShift. So I can use mvn clean install to build the application. Okay. This can be understood by those attendees who knows the application development using the Spring. Otherwise, you can use any of programming language you wish, like Angular, or like Python, PHP, anything. Anything can be converted into the containerized application. No problem in that. So if I would like to run the application, java-jar, and I know that in the target folder, my application is get converted into the jar. So if I'm running this application, you can see that my Tomcat has been started on the port number 8080. This is only to check whether my application is working or not. Okay. So localhost/home. I got my output. Okay, that my API is working fine as expected without any problem. So I'm stopping the application, and here I am having already a one Docker file I have created. So just to discuss, I am saying that okay, get the OpenJDK 17 Alpine. In this is the base image. So this base image is basically having one Alpine Linux operating system along with JDK 17. These two things is come up with this Alpine. And I'm only saying that copy this jar file from my current target folder to the container home directory, and container home directory is / because container is running as the root login. We have seen that in our last example. And then the entry point is the java-jar and run the application, java-jar and jar name. So only 3 statement is here. Now you know that in our Spring Boot application, we have created the fat jar. The Tomcat, the embedded Tomcat is very much within my jar file. In my jar file, I am having custom class files, means whatever the controller I have created, compiled version of those custom classes, along with the servlet container, that is the embedded Tomcat. So from the first line of this file, we understood that one Alpine Linux will come for me, 117 JDK will come for me. JDK and Linux, 2 things is set. Next, in my fat jar, I am already having embedded Tomcat. So runtime problem is solved. Runtime will be my Tomcat, embedded Tomcat. And the custom logic is my controller, my application. Entry point is this statement, java-jar, and then name of the jar. And the path is relative to the containers path. And containers path is where I have copied my jar file. So what I need to say, I will create image out of it. Podman build, then tag. I would like to take help. Build. So I can run podman build dot, means it will by default get the Docker file, D capital Docker file as the input, as the instruction set. Or I can say Docker build creds username colon password -t tag name. For this I was looking for. And -f can be used to provide custom Docker file name. We can change we can put this instruction from run execute entry point copy command we have seen in the Docker file, that we can put in some other file, and we have to provide the file name using the -f. So the most of the thing is not okay. So podman build -t, and I would like to name it OpenShift workspace. OpenShift workspace 01. Suppose I would like to this tag and dot. Again, when I am putting dot, it means I am saying pick the default instructions from the Docker file. Now you can see it is saying, okay, I am using this cached version of layer because that Alpine layer is already available with us. And then it is saying, okay, I am copying the content and I am setting up the entry point. And finally, I have created one image for you with the name of OpenShift workspace -01, whatever. Now check it. Podman images. So we can see that we are having one image, and this image is tagged with the local host, means it is my custom image, just we have created. It is not from the Docker IO, it is not from some any other public repository. It is from very much our own local host. And the size of this image is 344 MB. and image's ID is this. So now I like to run this image. So I will use podman here, podman run -d for detached -p for the port mapping 8080 outside 8080 inside and name of the image. If I'm running this, see podman ps, my image is running as a container and it has already bind the host machine IP address, host machine port, that is 8080, to the container 8080 port. Now if I run this line, I'm getting the output. See, I'm getting the output. So from where I'm getting this output? I'm getting this output from my container, from my Docker container or podman container. If I stop this, podman stop container ID, it will stop working. No. Okay. So we have seen the basics of podman, how to create podman Docker image, how to run the Docker image, how to go inside the container using the podman execute or Docker execute, and what is the importance of port mapping, port binding. So this is for the first session of our workshop. We have understood the importance of containerization, importance of Linux operating system knowledge in terms of using this containerized application. We have pulled one ready-made image from the Docker Hub, that is the Nginx. And we have created one custom Docker image from our very much own application, that is the web API, Spring Boot application. So first we have created simple application. We have created jar file. We tested it locally. Then with the particular jar file, with the help of this Docker file, Docker, with the help of this Docker file, we build a custom image in which our own application is getting inserted, and we run our own custom image as a container to check whether our application is running properly or not. So all these things for this first session. In the next session, we will see the OpenShift platform and we will see some advanced version of this containerization. There, up to this point, we have not talked much about scaling of the application. Okay, see, for the 5 instances I would like to run for my one API application server, how to do that. That scaling, failing, health checking, we will see in the next session, and we come back at 2:30 sharp. We will start our session from there. Anything more? Any question you want to ask? Any question till now?